This chapter will begin by considering the fundamental vision of the ecological economist. Of course, by doing so, we will also distinguish between the neoclassical approach and the ecological approach. In this lecture, in Part 1, we will talk about the big ideas of the pre-analytic perspective of the ecological economist. This pre-analytic vision is that there is an optimal scale of an economy that faces limits to growth. The economic ecologist sees the economic system as only a part of a much larger limiting whole, the whole being that of the Earth system, while the neoclassical economist sees the whole as the economy itself. Since the economy is not the whole, but only a subsystem, according to the ecological economist, we will describe an approach that will help us to define an optimal scale of the economic subsystem that is limited by the whole Earth system itself. And this will require us to consider the diminishing marginal returns of an economy that is in a continual growth mode, and ask at what point does this growth become uneconomic by growing past the point where the marginal costs begin to exceed the marginal benefits of growth. This, of course, will require a new paradigm shift in our thinking that requires us to move away from the neoclassical economic paradigm approach. In Part 2, we will use the powerful model of the circular flow diagram and Say's law to illustrate this necessary paradigm shift. The circular flow diagram will help us to understand how the economic subsystem has fundamental leakages and injections and a linear throughput and is limited by the laws of thermodynamics. But before we get started, it is worth our while to watch a TED Talk by Johan Rockström, Let the Environment Guide Our Development. Here, the actual whole system the economy faces is identified by 9 planetary boundaries. Let's begin by identifying what we mean by planetary boundaries that an economy may face. So now let's continue with our objectives from Part 1. But before we continue, as always, we must begin with a few definitions. Since we are now considering the economy as a subsystem, we must define what we mean by an open, closed, and isolated system. By an open system, we mean a system that takes in matter and energy and releases as output or waste both matter and energy. Of course, the example here is an economy. It takes in natural resources, including energy, for example, the sun, and releases output of goods and services, and waste as pollution. A closed system takes in or imports only energy and releases output or exports energy. Matter circulates within a closed system. Note that it does not flow through it, but circulates within it. The Earth may be a very close approximation to a closed system. An isolated system circulates both matter and energy. It doesn't have any inputs or outputs. It does not import or export anything. Can we use the universe as such an example? These definitions become important because we will find that if the Earth is a closed system, or worse, an isolated system, as the neoclassical model would have it, then the economy faces no limits. This means that at every point that an economy expands, there are no costs involved. This is contrary to the ecological model that assumes an open system and that the economy faces scarce, limiting resources, and something in the Earth must be given up in order to grow economically. There are opportunity costs involved with growth. When the economy grows, something must be given up. And this means that we must consider the limits to the economy's growth potential by considering the opportunity costs of continued economic growth. We are going to define the optimal scale or size of an economy to be where the marginal costs of expansion just equals the marginal benefits. And as economists, we define the marginal cost to be the incremental opportunity cost of expansion. The optimal scale is not strange to microeconomics. Question: at what level of production does one stop making widgets? When the cost of producing one more widget at the margin produces more costs than the profit or benefits received from producing one more unit. We call this rule when the marginal costs just equal the marginal benefits. If producing one more unit still brings in some profit, even if the additional money for this additional unit is less than the amount of the previous production unit, it is still profitable to produce that unit. So as the marginal benefits of producing one more unit is still greater than the costs, it is worthwhile to produce because it brings in additional money. Only when the cost begin to exceed the profit of an additional unit does the firm stop producing additional units. We call this the stop rule, when the marginal benefits just equal the marginal costs. Strangely, there's no such rule of when to stop in the macroeconomy. Why? Because according to the neoclassical model, there are no opportunity costs for growth when the economy is viewed as an isolated system. This worldview works in an empty worldview, when the opportunity costs are small compared to the benefits. It's really difficult to seriously consider the limits to growth in such circumstances. When economic thought was developing in the late 1700s, we had an empty worldview. Resources were not quite as scarce as they are today, so the opportunity costs of economic expansion was not quite as great. However, in a full worldview, one that we face today, where the economy takes up a large portion of the ecosystem, the opportunity costs of growth become so large that we can actually have uneconomic growth, in which welfare actually goes down as the economy expands. This is when we face the limits to growth as the economy begins to expand to the point of consuming the whole, and the marginal costs begin to exceed the marginal benefits. One may wish to consider not just the absolute limiting factors, such as the 9 planetary boundaries as discussed by Johann Rockström in the TED Talk, Let the Environment Guide Our Development, but there is also the welfare of a psychic entity. Is it possible that the utility of bigger and bigger homes brings smaller and smaller satisfaction, while the opportunity costs of loss of diversity and wilderness ecosystems become increasingly scarce? It becomes harder to experience the wilderness. We must drive further, fight the pollution, traffic, and crowds, fill out climbing permits and paperwork, and then face the garbage as we climb and scale a magnificent mountain peak. Neglecting the biophysical basis of economics gives a false picture, but neglecting the psychic basis gives us a meaningless picture. The pre-analytic vision of ecological economics is expressed in this figure. Stanley Jevons asked the question, when does the effort of working begin to exceed the value of the wage to the worker? An ecological economist asks an analogous question. When does the cost of us displacing the Earth's ecosystem begin to exceed the value of the extra wealth produced? Here in this diagram, you can see that B is where we want to be. E, on the other hand, represents the grim life at carrying capacity. And D, well, the end of the world as we know it. Why do neoclassical economists not see the problems associated with ideas of the full world, diminishing marginal returns, and uneconomic growth? Well, first, they believe we are still living in an empty world, and thus the marginal utility is still very large relative to the marginal disutility. And secondly, technology will save the day, preventing the marginal disutility from ever becoming too large relative to the marginal utility. And finally, there's a paradigm problem. The economy is simply not seen as a subsystem of a larger ecosystem. The economy is an isolated system that can grow indefinitely. Where conventional economics espouses growth forever, ecological economics envisions a steady-state economy at some optimal scale. Each is logical within its own pre-analytic vision, and each is absurd from the viewpoint of the other. The difference could not be more basic, more elementary, or more irreconcilable. Kenneth Boulding once warned that anyone who believes exponential growth can go on forever in a finite world is either a madman or an economist. A paradigm shift is clearly needed in today's age. In the next lecture that follows, we will discuss the paradigm shift with the use of the circular flow diagram and the ideas of linear throughput.